Hello students, I am SB Bambre teacher, RBH Vidyalaya Malegaon Camp. Part 1st, chapter number 2nd, work and energy. In this chapter, you have learned work, energy, mechanical energy, law of conservation of energy, and free fall. Point is the work. What is meant by work? Work is when a force applied of an object causes displacement of the object. When a force applied of an object causes displacement of the object, work equal to force into displacement. Work done by a force acting on an object in the product of the magnitude of the force and the displacement of the object in the direction of the force. Therefore, work equal to force into displacement. Look at this picture. The girl writing in her notebook. A boy playing with a ball. A girl operating a remote. A person walking with a bag on his shoulder. In all these cases, the work is done. Generally, any mental or physical activity is referred to as work. When we walk or run, in the energy in your body used to the necessary of the work. Look at this picture. Meenakshi wants to displace a wooden block from point A to point B along the surface of a table as shown in a picture. She has used the force F for the purpose. Has a total energy been used to produce acceleration in the block? Yes. Force. Which force have been overcome using the energy? The force is friction force and gravitation force overcome using that of the energy. These pictures you have seen in the event depicted in the picture B and C. When a child in picture B, when a child pull a toy with the help of a string, the direction of the force is different from that of displacement. Similarly, in picture C, when a large vehicle down a small one, the direction of force and the displacement of the different. In both these cases, the direction of the force make an angle with the direction of displacement. Let we see how to calculate work done in such cases. When a child pull a toy cart, force is applied along the direction of the string while the cart is pulled along the horizontal surface. In this case, in order to calculate the amount of work done, we have to convert the applied force into the force acting along the direction of the displacement. The applied force and F1 be the component in the direction of the displacement and S be the displacement. The amount of force done is given by F1 is the force and S be the displacement. Let F be the applied force The force F is applied in the direction of the string that made angle with the horizontal. Let theta be the angle that the string make the horizontal. We can determine the component F1 of this force F, which act as the horizontal direction by means of trigonometry. Look at this figure. In trigonometry, cos theta equal to base upon hypotenuse. Cos theta equal to F1 upon F. F1 equal to F into cos theta. Thus, the work done by force F1 is W equal to work equal to F into cos theta into displacement. Work equal to F into S cos theta. Use the displacement of force used for the displacement. Next point, unit of work. Work equal to force into displacement. The SI system, the unit of work is joule. 1 joule equal to 1 Newton into 1 meter. CJ system, the unit of work is erg. 1 erg equal to 1 dyne into 1 centimeter. Therefore, 1 joule equal to 10⁷ erg. Next point is a positive, negative and zero work. First is the positive work. The positive work is when a force and displacement are in the same direction. When a force, displacement are in the same direction, the value of theta is a 0 degree. The work done by the force is a positive. For example, pushing a stall vehicle. The work done by the force is a positive. Second is a negative work. The force and displacement are in the opposite direction. The theta value is a 180 degree. The work done by the force is a negative. For example, walking down a staircase, climbing a tree. Third point, zero work. When the force does not causes any displacement, or when the force and the displacement are perpendicular to each other, the theta value is a 90 degree. The work done by the force is a 0. The example is tying a stone to one end, a string, and swing in a round and round by the other end of the string. All the some example of the work. The example of first, calculate the work done to take an object of mass 20 kg to a height of 10 meter. G value is a 9.8 meter per second square. Given M equal to 20 kg, S equal to 10 meter, G equal to 9.8 meter per second square. Therefore, the formula of force equal to M into G. The value of M is a 20 and value of G is a 9.8. The minus 9.8. The minus 9, the negative sign is take place. The negative sign is taken because the displacement is opposite to the direction of the force. Minus sign is a negative sign is taken because the displacement in the opposite to the direction of the force. The F equal to 20 into minus 9.8 is minus 196 Newton. Therefore, work equal to F into S. The force is a minus 196 into displacement is a 10. The answer is a 1916 joule. The work is a 1960. The negative sign appears because the direction of the force is opposite to the direction of the displacement, so that the work done is a negative.